So the topic that we are sharing today is binomial theorem, and this topic itself is being assessed in both your additional mathematics as well as your AS level mathematics. I will be covering 6 types of question. Each of them has different attribute and basically cover all the various type of question might appear in your exam. Before that, we have to go through the core formula. So we have a plus b to the power of n, and through this formula itself, for you to identify the term the question is asking for. The a to the power of n here is your first term, and then you will see a matrix-like bracket over there that has n and 1 in it. So that one, you have to break it down and treat it as nc1 times a to the power of n minus 1 times b to the power of 1. So that will be your second term, followed by the third one and the n term here. So if you were to break down the n term, it's actually ncr, a to the power of n minus r, and b to the power of r. And most of the students is being confused by the last thing over there listed as b to the power of n. That is actually your last term, where ncn times a to the power of n minus n times b to the power of n. Reason why they only include bn as the last result is because, for example, when your n is 3, so 3c3 will get you 1, and a to the power of 0 will have a direct result of 1. So they straight up ignore the 2 variables at the front and only include bn as the last term.
So another thing about this topic is that you need to be able to identify how many terms the equation can actually expand. So how do you actually trace this is by looking at the power of the equation given. So numbers of terms that one equation can expand is always through the power that you have added by 1. So for example, if I have an equation with a plus b to the power of 5, the maximum terms I can actually expand it will be 6. So this particular part is actually very important because some of the question will need you to use your own justification to select a specific term to solve their question. So I've already included an example later on. You just have to take note on this.
So there's a continuation on this particular formula where n is a positive integers and nr equals to n factorial divided by n minus r factorial times r factorial. This is slightly tricky and it's very hard for me to give you some example over here. But things to take note is that the factorial there actually means this. So n factorial can be treated as n times n minus 1 times n minus 2 times n minus r factorial. So that's the details for this particular part. So I will share you some question later on so that you can understand the second part of this equation better. So question that's surrounding the core formula, the one at the top, is relatively easy. The tricky one is always being assessed on the one that has factorial involvement. So I will go through some questions later on. A couple of things for you to take note is that in binomial theorem question, they always ask you to find the first n term. This every term down, you can simplify it. And the other thing is you need to know how many terms you can actually expand. So do not blindly follow the formula and you couldn't make your own justification. Okay, so later on I will show you some example on this, as well as find the independent term or coefficients of x to the power of n. So this is a continuation from your part 1 question. So a couple of skills is required to solve this, which is you have to analyze and compare. You have to plug in the correct variables to get the right results. as well as determine which variables should be multiplied together to fulfill the question requirement on identifying the independent term, identifying the coefficients of x to the power of n. It might look a little bit vague now. So let's go through the question so that you can understand this topic better. So in example 1 here, find the first 4 term in the expansion of 2 plus x to the power of 6 in ascending powers of x. So for this question number 1 here, okay, remember that I asked you to assess yourself on identifying how many terms you can actually expand. The maximum term that you can expand from this is 7. How did I know that? It's because it is always more than 1 of the power. So we have power of 6 over here. Just add 1, then you know you can actually expand it to 7 terms. So let's get back to the question. So this, our A now will be 2, our B is treated as x, and our n is 6. So this orange column here, you don't have to list it down, it's just for your own illustration. So let's break down the formula, then I should get the following results. That goes by 2 to the power of 6 plus 6c1 times 2 to the power of 5 times x to the power of 1 plus 6c2 times 2 to the power of 4 times x squared plus the fourth term here is 6c3 times 2 to the power of 3 times x to the power of 3. So key in your calculator and identify 6c's one value, multiply 2 to the power of 5, then you get the results as 192x, and 62 times 2 to the power of 4, then you get 240 x squared, and 63 times 2 to the power of 3, then you get 160 x cubed. So this is your first 4 terms that they are looking for. So in part 2, find the coefficient of x squared in expansion of 1 plus 3x, 1 minus x, 2 plus x to the power of 6. So you're required to multiply the 1 plus 3x and 1 minus x together first. Then you get the result of negative 3x squared plus 2x plus 1. Then only you align them, the first 4 terms that we identified earlier, and this negative 3x squared plus 2x plus 1 together. Okay, so until now, this is where I mentioned earlier, you have to determine which variables multiplying together will get you x to the power of 3. So we have negative 3x squared multiplied with 192x. We have 2x multiplied with 240x squared. And we have 1 multiplied with 160x cubed. By doing so, you'll be able to derive the following formula. It goes by negative 3x squared times 192x. You will get the result of negative 576x cubed. So from 2x multiplied with 240x squared, you will get 480x cubed. And the last one, 1 times 160x cubed, then you will get 160x cubed. Run the calculation, then you will get 64x cubed. The coefficient here means the numbers in front of the x cubed. So for that, you have 64 as the final answer. Moving on to example 2, we have the coefficient of x squared in expansion of 2 plus px to the power of 6 is 60. So we have to identify the coefficient of x squared here through the expansion. So first thing first, I know that the maximum term I can expand will be 7 because 6 plus 1. Okay, I took the power, add it by 1, then I will get 7. However, the question is only asking for x squared. So for me to get to x squared, this will actually be my third term. Okay, I'm going to show you why did I say it's third term. So through the formula, I identify my A as 2, my B is px, and my n is 6. Okay, plug in accordingly. Then I stop at third term immediately because, as you can see at the last part, my b, which is px here, is being squared. By utilizing this, 6c2 times 2 to the power of 4 times p squared x squared, I will get the result of 240 p squared x squared. So this coefficient here is actually 240 p squared. Put it equals to 60 as given by the question. Remove the 240 to the other side, square root it, and as the question mentioned, the value of p is a positive constant. So after gotten the variables out from the square root, I only took the positive 1. So my final results, I listed it as 1 over 2. So this is why you actually can skip a lot of workings if you are very familiar with the fundamentals. So it's always good to practice, to determine how many terms you can actually expand, and when they are looking for specific coefficient of x to the power of something, you can trace it back and identify it immediately, so you can skip out a lot of works when solving this type of question. So looking at second question here, use your value of p, find the coefficient of x squared in expansion of 3 minus x, 2 plus px to the power of 6. So I brought down the first three terms that I identified earlier, incorporate the p value into it. So I will get my results as 3 minus x multiplied with 64 plus 96x plus 60x squared. So you will see me put a dot over there. It's because I'm not sure whether the variables at the back should be considered in this calculation, because the maximum coefficient that they wanted is x squared only. So if I continue to expand, I will get x cubed, x to the power 4, which is irrelevant to the question. That's why I only use the first three terms to run the calculation here. So to get to x squared, I need to take my 3 multiply with 60x squared, and I took my negative x multiply with 96x. Through that, I will get the calculation as 180x squared minus 96x squared. Then I will get the final results as 84x squared. So this 84 is our coefficient of x squared here. Moving on to example 3, find the first three terms in expansion in ascending powers of x of 3 minus x over 9 to the power of 6. So this, our a will be 3, our b will be negative x over 9, and our n will be 6. Substitute it into the formula, then you will get 3 to the power of 6, which is 729. 61 times 3 to the power of 5 times negative x over 9. Then you will get negative 162x. Then you have 62 times 3 to the power of 4 times x squared over 81. You will get 15x squared. Okay, reason why I cancel off the negative is because it was being squared, and I changed the 9 into 81. So this will be your first three terms of this question. So find the term independence of x in expansion of. So as you can see, there was another bracket with square being introduced here. Okay, we already find the first three terms of the variables at the front that goes by 3 minus x over 9 to the power of 6. You're required to expand the new formula introduced to you to the fullest, so you can run the manual calculation to trace terms independence of x. So some of you might confuse right now what is term independence means. It's actually referring to no x at all, or you can take it as x to the power of 0. So let's run the calculation first. Now my a is x, my b is -2 over x, and my n is 2, which means that I can maximum expand it in 3 terms. That goes by x squared 2c1 times x times -2 over x plus 2c2 times x to the power of 0, 4 over x squared. As mentioned earlier, if it's the last term, you can actually skip these steps and just square the b value. So you will get x squared minus 4 plus 4 over x squared. Incorporate this, okay, multiply it together, list it down first. Then I determine which two multiplied together will get me the term independent, where x to the power of 0. So I took 729 multiplied with -4, and I took 15x squared multiplied with 4 over x squared. You're not necessary to multiply all the variables available together. You just have to fulfill the question requirement. So the excess variables in this question will be the -162x and the x squared. They are not being considered during the calculation to identify terms independence of x. So after you multiply these two together, you will get -2916 plus 60. So the final answer, -2856. Moving on to example 4. Find the first two terms in ascending powers of x in the expansion of 2 plus bx to the power of 8. Can be written as a plus 256x plus cx squared. So find the value of a and b and c. So this part is different from what we have done earlier. As per usual, you have to expand and find the first three terms first through the formula given. So our a is 2, our b is bx, and our n is 8. Through the expansion, you will get 256 plus 1024 bx plus 1792 b squared x squared. So compare this accordingly. So you have to look at the x and the x squared so that you can know which one to compare together, not to confuse yourself. So those without x here is a and 256, hence your a will be 256. Whereby for the 1024 bx is being compared to 256x. So your b will be 256x divided by 1024x. You will get your final result as 1 over 4. As for the last one, we have 1792 b squared equals to c. C equals to 1792 times 1 over 4 squared. So you take 1792 times 1 over 16, you will get 112. So same thing, a new equation was being introduced to you, which is 2x minus 3 over x to the power of 2. Expand it to the fullest, so I know that it can be expanded into 3 terms. So run the calculation. A is 2x, b is -3 over x, and n is 2. After the calculation, you will get your final results as 4x squared minus 12 plus 9 over x squared. Incorporate the results that you've gotten for your 2 plus bx to the power of 8. You now have this new formula here, which is 256 plus 256x plus 112x squared multiplied with 4x squared minus 12 plus 9 over x squared. Determine how do you identify independence of x. So I took 256 multiplied with -12. I also took 112x squared multiplied with positive 9 over x squared. You will get the results as negative 3072 plus 1008. Add these two up, you will get negative 2064 as the term independent. So remember, take note on the signage whether the variables that you're using is positive or negative to avoid any occurrence of silly mistakes. Moving on to question 5. This is where it gets tricky. So they will incorporate the second part of the formula that I mentioned earlier. So let's show you like the example over here. So in this question 1, use binomial theorem to expand a plus b to the power 4 and given each term in its simplest form. So the only things changed from the formula is that your n was listed as 4 here. So through the expansion, I ran a calculation and I gotten a to the power 4 plus 4a cubed times b plus 6a squared b squared plus 4ab cubed plus b to the power 4. So this will be the term that you have. Moving on to question 2, find the independence of x in the expansion of 2x plus 1 over 5x to the power of 4. Let's expand it accordingly. So things to take note is that we can actually utilize what we have gotten earlier. Okay, just substitute a, b, and n's value into the formula we gotten earlier. So a now we treat it as 2x to the power 4. So 4 multiplied with 2x to the power 3 times 1 over bx plus 6 2x squared times 1 over 5x squared plus 4 times 2x times 1 over 5x cubed plus 1 over 5x to the power 4. You will get your results as 16x to the power 4, 32x squared over 5, 24 over 25 plus 8 over 125x squared plus 1 over 625x to the power 4. So our term independent here referring to the one without x. So we have 24 over 25 as our term independent. So they really like to assess you on this, where a has x, b also has x, and one of them is at the numerator, one of them is at the denominator. For this, you really need to be able to identify what's the maximum term you can expand and what's the possibility when these two multiply together, you will get independent terms of x to the power of 0. You will get the independent term. So practice more, okay, don't just rely on this video, then you should be able to nail this topic. The continuation from this part is the coefficient of x cubed in the expansion of 1 plus x over 2 to the power of n is equal to 5n over 12. Find the possibility of positive integer n. So our a is now 1, our b is x over 2, and our n is still n. So I expand it first, and I know that at the fourth term, I will get my coefficient of x cubed. That's why I highlighted red over there. Okay, because a don't have x, and our b, when it's multiplied by power of 3, then only we can get to x cubed. So only focusing on that, I written it as nc3 times 1 to the power of n minus 3 bracket x cubed over 8 equals to 5n over 12 x cubed. So remember, 1 to the power of anything will still be 1. So I first cancel it off. Here comes the second part of the equation. So the nc3 there can be broken down as n factorial over n minus 3 factorial 3 factorial. So I've broken down my n factorial as n times n minus 1, n minus 2, n minus 3 factorial. So the n minus 3 factorial has repeated on both numerator and denominator, so they are being cancelled off. So I will left a balance of n times n minus 1 times n minus 2 over 3 factorial. Multiply it with x cubed over 8, you will get 5n over 12x cubed. So I first get rid of the x cubed and 8, then I divided it and I get the results of 40n over 12, and the 3 factorial I changed it as 6. Next part is I shifted the 6 to the other side, divide become multiply, and the n become divide. So I gotten n minus 1, n minus 2 equals to 20. Run the calculation, you get the final equation as n squared minus 3n minus 18 equals to 0. And this through the factorization, so I didn't show you the detailed process on this, okay, because if you are able to sit for AdMaths and A-level mathematics, you should already understand how to factorize this part. So you will get n minus 6 and n plus 3. Okay, get rid of the 6 and the 3 to the other side, you get n equals to 6 or n equals to negative 3. However, remember the question they asked for positive integer n, so our n will not be considered as negative here. So final results, n will be 6. So feel free to pause this, trace it back to the workings, re-watching it to understand this part better, because it's very important and this is the hardest type of question that might appear in your exam. Moving on to the example 6, we have similar question from the front. Given that n is a positive integer, find the first 3 terms in the expansion of this. So the first 3 terms will be as below. Our a is 1, our b can be written as x over 2, or you can leave it as 1 over 2x, and our n is still n. By substituting it into the formula, then you will get your result as 1 plus n factorial over n minus 1 factorial times 1 factorial times x over 2 plus n factorial divided by n minus 2 factorial times x squared over 4. So 1 to the power of anything will still be 1. Okay, take note on that. That's why I leave 1 over there. And our n factorial can be broken down into n times n minus 1 factorial. So both n minus 1 factorial will be cancelled off. Then the one in the back, n factorial can be broken down into n times n minus 1 times n minus 2 factorial. So cancel the 2 n minus 2 factorial. So you will get your results as 1 plus n multiplied with x over 2. 1 factorial is actually 1, so I didn't list it over there. And our n times n minus 1 divided by 2 factorial. 2 factorial results will be 2. Multiplied with x squared over 4. So that's the full details of this first 3 terms. So incorporate the results that we've gotten earlier. They are looking for a coefficient of x squared, and it is 25 over 4. So I listed 2 things down, and I'm determining which multiplying together will get me x squared. So I know when my 1 multiply with n bracket n minus 1 over 2 times x squared over 4, it will result in x squared. And by negative x multiply with n bracket x over 2. Run the calculation, then you will get both results equals to 25 over 4x squared. I extracted the x squared from both of them, so I'm left with n bracket n minus 1 over 8 minus n over 2 equals to 25 over 4. the x squared was being cancelled off because both of them is repeating. I then move on, multiply the 8 to the other side. Okay, expand the brackets, then I get n squared minus n minus 4n equals to 50. N squared minus 5n equals to 50. Adjust it, run the factorization process, then I gotten n plus 5n, n minus 10. So your respective n results could be n equals to negative 5 or n equals to 10. And do take note that for n in binomial theorem, we will not accept it as negative. So your final answer here will be 10. So this is pretty much it for this particular topic. Basically covered all the types of questions that might come up in your exam. Feel free to utilize these free resources as well as do more practice through glancing through all the past year. Okay, the more you practice, the better it gets. So if you have friends that are struggling to understand this topic, you can always share this video to them. And I wish you all the best in your upcoming examination. Thank you.